fundamentals of geometry. We're starting with points, lines, and planes. There's a link down at the end, and when I finish this slide, I'll ask you to go to that link because the guy on the video has a great explanation of points, lines, and planes. For this slide though, I just want to address some of the notation differences between his video and what's expected in the Irish course. So let's start with lines first of all. So a line there goes through the points A and B, and we know it's a line because it goes on forever up to the top left through A and forever down through the bottom right through B. That's denoted by the arrows. And if a line goes through 2 points, to describe the line we describe it according to the points it goes through. So we call that line AB. Just AB are the 2 points it goes through. Okay, the second thing, if you have a line that goes to points A and to point B, so goes between them but doesn't go beyond them, like is shown in the diagram there, we call that a line segment, and we represent that in Ireland with notation like so. So we have those square brackets. The square bracket on the left hand side says it doesn't go beyond A. The square bracket on the right hand side says the line doesn't go beyond B. So it's a line segment. And then we have something in between the two called a ray. So a ray stops at one point and goes through the other one infinitely into the distance. So it stops in this case at B and it continues on beyond A. And because it's somewhere between a line and a line segment, the notation is somewhere between a line and a line segment as well. In this case, it stops at the point B, so that square bracket tells you that it stops at the point B. No square bracket next to the A, meaning it continues beyond it. And the second option then, with this ray, you've probably guessed it already, you should have a square bracket next to the A but none next to the B. Okay, so pause the video, go to the YouTube link, watch the video, and then come back for the second slide. I'm going to keep going, however. Okay, the second thing we want to cover is what's called axioms. Axioms are statements that we believe to be true, and we do not need to prove them or verify them every time we do maths. We just say they're true, that's fine, we work with them. So the first axiom that we believe to be true is there's only one line between a pair of points. So if you had points A and B, you could only draw one line that goes between those. Obviously, you can draw one line segment that goes between those, and you can draw 2 types of rays that go between those as well. Okay, a second axiom that I'm not going to write down here, but that I'm going to state. The shortest distance between A and B is always that line segment AB. So the shortest distance between A and B is the line segment. Okay, the third one. The distance between 2 points is always positive, so the distance between A and B is always positive. And after the semicolon, I've given that in mathematical notation. We have 2 vertical lines either side of the AB, and when you write the 2 vertical lines with the AB in the middle, that represents the distance between A and B. So we have the distance between A and B, the greater than sign, and the 0, so the distance between A and B is greater than 0. The next axiom, the distance from A to B is equal to the distance from B to C. And that should make sense because if you walk from A to B, that would be the same as walking from B to C distance-wise, even though the direction is different. After the semicolon again, I've written down the notation for that. So the 2 parallel lines with AB in between it, the distance between A and B, and the 2 parallel lines with BA between it, that's the distance BA. So that says the distance between A and B equals the distance between B and A. Okay, and the last one then, if I introduced a point C on the line, so now we have A, B, and C. C is somewhere between A and B. Then the next axiom is the distance between A and C plus the distance between C and B equals the distance between A and B. And that again should make sense. If you walk from A to C and then you walk from C to B, that should be the same distance as walking directly from A to B. Okay, and that's it.